We would like to welcome you to Dr. Chris Stryker's session, A Simple Framework to Help Students Develop Critical Thinking and Problem-Solving Skills. Please remember to remain muted unless you've been given the directive to unmute yourself. But however, as you all are already doing, you can find us in the chat where you can feel free to leave questions or comments at any time during the presentation. And now I'd like to turn it over to Dr. Chris.
Thank you very much, Tiki. Good morning, everyone, or good afternoon, or good evening. I'm Chris Stryker, as Tiki said, and welcome to the presentation. I'm going to be talking today about a framework to help students develop critical thinking and problem-solving skills. I will not be monitoring the online chat during the presentation. I'm already at a bit of a disadvantage because the way Ring Central and most of these conferencing programs work, I can't see the next slide until I actually press the space bar and advance. So if I pause a bit, forgetting exactly what the next slide was, you'll know why. Anyway, I won't be monitoring the chat, so you might want to write down your questions, and we will have time for question and answer session at the end, and you can ask them then live by voice if you wish. Anyway, surprise, there's a global pandemic, and you've got a limited time to change everything that you do, whether you're a faculty member, a student support, student affairs member. You've got to switch it all to an online format. If you're like me, your reaction is probably somewhere here in the second row. It's been a tough time for all of us, and the problems, it seems, come day after day. People are adjusting to it a bit better this week than 3 weeks ago, but it is still a very challenging situation. And my advice to myself, my students, the people I work with, is that the best approach is to keep calm and actually simplify what it is that we're trying to do in terms of learning, in terms of teaching, in terms of support. We are forced by our circumstances to concentrate on a more limited selection of what we can do. So whereas before we might have had a whole spectrum of things that were possible in our professions, now we have a narrower spectrum that we need to focus on. It's interesting to read some of the literature about what people are doing during this massive shift to online teaching. And this was one article recently in the Chronicle of Higher Education. I was interested to note the image that's on the screen in the picture, because this is precisely what's happening at my institution and probably yours as well. It's this shift to video conferencing as a method of instruction. I've been teaching courses online since 1995, and yes, there were courses online back in 1995. We didn't use interactive video, we used other technologies, perhaps better technologies in terms of interaction and safety. There was no Zoom bombing, for example, in those days. But looking at this pivot, this switch to online instruction that's taking place, I'm reminded of one of my favorite films, The Matrix, and perhaps you're familiar with this one as well. One of the key elements of The Matrix was this division between what we thought was the real world and what the real world actually was. And the character Morpheus was kind of a teacher in the film, and the awakening of the main character into what the real world was a central theme. This is a scene from the movie, and that's how it looked to the characters, that they were in a hallway and there was a fight going on, but really underneath this was this computer construct, the Matrix, that was fooling us all into thinking that it was the real world. Now, why am I talking about the Matrix? Because that's what I was instantly reminded of with this shift to an online teaching and learning and supporting environment, where the virtual has become our real, in a sense, as we are grappling with working with students at a distance. And for me, this highlighted a division that's always existed that we, over the years as educators, may have paid more or less attention to, this split between what life is like in the classroom and what life is like in the real world. So school versus world, that dichotomy, that division. And since as long as I can remember, and I've been in education 35 years, teaching at the high school level, college level, grad school, there's always been this emphasis on infusing more of the real world in our classrooms, implying that somehow our classrooms are not authentic real world experiences. This emphasis that things that happen in the real world are crucial to bring into the classroom. And this paragraph is from that last website. Take a moment and read it. So this emphasis that project-based real-world learning is successful in developing lifelong learning skills, things that students urgently need to succeed in the real world. So that difference between school and real has always been something that I've thought about and been concerned about. In a visual way, you can picture our school environments as something like a playground. Our classrooms are restricted. There are a certain number of things that our students are permitted to interact with, and it's always done with supervision. And indeed, there's a barrier between what happens in classrooms and what happens in the real world. Our things that our students can interact with are textbooks and skills that we wish them to develop, so-called critical thinking skills. Of course, there is an ample amount of help that educators provide students. They're not just left to run around the classroom, so to speak. We try to help them solve problems. Unfortunately, the advice, the methods that we typically use, typically try to communicate to students, are relatively poorly defined, and as such, relatively weak. How does telling a student that they should identify a problem or explore or take action, how do those things really develop critical thinking and problem-solving skills? On top of that, the problems that our students are exposed to in that confined space of a classroom setting are relatively simplistic. We have a limited amount of time to solve problems within a week or a semester. It's not something that students can take years or months to develop solutions to. So the problems are relatively simple, and the solutions are, in turn, relatively simple. It is a relatively straight line, in my opinion, from the thinking that our students are supposed to engage in to the solutions, to the ideas that they will develop in solving problems within a classroom. So that notion of a confined space, that dividing line between the real world and the classroom world is, I think, a real one. And I'm going to call your attention to a special section in this image. It's the block there, the chairs that keep the people from getting to the outside world. I think that exists very much in our classrooms. We prohibit students from getting too far outside the bounds of our class. We also inhibit the real world from coming in too far into our classrooms. So this notion of a real and a simulated world that was presented in the movie The Matrix is, I think, an important concept for educators to understand. That the problems we introduce our students to are simplified versions, for a good reason, but nevertheless simplified versions of real-world problems. In the real world, our problems are much more complex, much more challenging, much more unclear. Problem solving is not a simplistic task. There are a bunch of competing solutions. The help that students used to get in classrooms, much more limited, if it exists at all in the real world. The help that students will have comes from themselves, and they've got to put on their thinking caps, they've got to get a cup of coffee or whatever, and engage with the problems that await them in the real world. I remember the first time that I saw a Rubik's Cube, and I'm not a big puzzle solver. It seemed that every time I turned it, I was only making it worse. Indeed, I still haven't solved the Rubik's Cube. They are particularly annoying to me. But that is a great example of how it is not a straight line or even a mildly curved line, bent line between an idea and a solution. Instead, students face a situation like this, where an approach to solving a problem has many branches, some of which are productive, some of which aren't, but even taking that first step is daunting, confusing tasks to students. Wouldn't it be great if, as educators, we could support students, we could help them identify a few more productive paths than just wandering around hoping to find solutions to problems. This is at the core of my presentation today. Accessing these critical thinking skills, actively activating them in students' minds, getting them to develop their own problem-solving approaches. So I always have a bit of foundation before my presentations, and that's it. Why is this important? I hope that you have an appreciation for that, and we'll start with the presentation proper. I'm a computer scientist. It's interesting that I would be addressing a conference of student affairs professionals. I currently work at a place called the Center for Excellence in Teaching and Learning, CETL, at Qatar University. I don't do much computer science there, though, and that explains why I'm talking with you today. Instead, I talk with faculty and staff at Qatar University about teaching and learning, about ways to improve our approaches to teaching and learning. And a large number of attendees at my various presentations are student affairs professionals. And they run a number of services on our campus and come to my workshops because I talk about teaching and learning. They do a lot of work with the what's called SLSC, Student Learning Support Centers on campus. And like all of us, they have pivoted to supporting students at a distance because of the pandemic. And this was an announcement they sent recently where they're offering Blackboard support through the SLSCs. So it's not perhaps that surprising that a computer scientist would be talking with you. And you might recognize my last name. I am married to somebody you probably do know, Courtney Stryker, who is a student affairs professional. So there is more than a casual connection there. So a theme going forward in my presentation is a saying in English that everything old is new again, that somehow we keep finding things in the past that resonate with the future. And that is certainly true with this particular book. A friend gave it to me. I'm not embarrassed to say, but I'm somewhat surprised to say they gave it to me in 1978. So quite a while ago, and I still have the book, and I especially still use one of the opening paragraphs from the book, or well, not really a paragraph, but sentences. And here they are. That has stuck with me because I think that it's quite powerful. And it definitely has bearing on this notion of problem solving. The better you get at solving problems, the faster you're able to solve them. The fewer possibilities, the fewer dead ends, the fewer distractions that you have. But beginners' minds, there are many, many possibilities. There aren't those practice responses. In experts' minds, it might be relatively simple to go from an idea to a solution. But in a beginner's mind, we've got this multi-path approach. Edison said something that's instructive. It's a great saying. Genius is 1% inspiration and 99% perspiration, but it's not very reassuring. If you are attempting to solve a problem, Edison's saying seems to imply that not a lot of thinking is needed, but an awful lot of hard work is required. And that's true in some circumstances, but that is a daunting message to give to students, that, wow, you don't have to think a whole lot, but you really do have to work. Certainly work is involved, but there has to be, in my mind, some method that reduces this problem space, that helps people solve problems, that unlocks a set of approaches, a set of responses that makes this task easier than 99% perspiration, if you see what I mean. I said everything old is new again, and indeed we'll continue with this kind of back to the future focus here. Let me take a sip of water too. Hold on. Specifically, let's go back to even earlier, 1945. I wasn't born yet. I wouldn't be around for another 17 years, but this fellow was around. Who is he? Well, we'll find out in a minute. However, the person wrote this paragraph, and I'm going to be quiet while you read it. Let me call your attention to that section. It's a little bit sad to see that in 1945, well, of course, wars raging around the globe and things, problems in politics, problems in science, problems everywhere. We've still got those same problems today. That's a little bit sad. But it is enlightening and hopeful that someone saw from that perspective in 1945 that problem solving is a natural human act. And that there should be a general set of approaches that we can use to tackling all sorts of problems. You may have gleaned from the last sentence that this person had something to do with mathematics. And that's true, but the methods for solving problems are not restricted to mathematics. The person in 1945 who wrote those words and whose picture I showed was none other than a mathematician named George Polya. And this is his book, written in the same year, How to Solve It. I remember encountering this book in college, and I thought that this would be a fantastic resource that would help me as a computer scientist, and I have a bit of a background in mathematics. I thought this would be a fantastic resource that would help me solve problems. How could I take a question and apply a method to get an idea that would yield a solution? Indeed it was, but it wasn't what I expected. Instead of a catalog of methods to solve all sorts of different problems, one could imagine a very thick book for such an approach. His approach surprised me. What Polya created were a bunch of what are called heuristics. This word is new to many of you, I would imagine. It certainly was to me at the time. And heuristics are general strategies to help people solve problems. Not a guaranteed method, but instead something that generally works. In English, we call these rules of thumb. That you do something because it's generally a good idea to do. The actual definition of the word heuristic is from the Greek word to find or discover. And if you look it up in the dictionary, a heuristic is something that enables a person to discover or learn something for themselves. That's perfect. That's exactly what we want as educators. We don't want to tell students exactly how to solve a problem. Instead, we want to help them find their own solutions. So heuristics are generalized hints. In the context of solving a puzzle, specifically a real-world puzzle, I'm sure you've all solved puzzles. I don't particularly enjoy these either, but my mother did. We always had a puzzle on a table in the living room in the wintertime. In the US, and it was snowy, you couldn't go outside, so she liked to build puzzles. And people who have solved puzzles, what are some heuristics that you use to solve them? I can remember something from very early on in my life that my mother said. But what do you have? What advice do you have for solving puzzles? Don't answer now, just think to yourselves. Well, the piece of advice that I remember my mother saying was start by looking for corner pieces. They're easy to spot. There are only 4 of them. After that, look for edge pieces. They're also easy to spot. There are many more of them than there are corners, but that is a way to approach solving a puzzle. That is a perfect example of a heuristic. Does it always work? No. You may not be able to find the piece, you may not know where it goes, but it is a rule of thumb that allows you to begin making progress. Polya also wrote these words. That is extremely important for educators to impart to students. There is that real world, classroom world split, again, where problems seem to have solutions that just follow as a matter of course. You start with a problem, oh, and there's the solution. That's not the way that it works in the real world. As Polya points out, problem solving begins with guessing, and not always a good guess. The art of problem solving is in refining your guesses, learning which ones are better, factoring out those that are not, and getting better over time at this process of approaching problem solving by guessing. That is an awareness that I have rarely seen teachers impart in classroom settings. So that's what we want to do with our students. We don't want to, as the saying goes, maybe you've heard, teach a man to fish, I'm sorry, give a man a fish and you feed him for a day. Teach a man to fish and you feed him for a lifetime. So we don't want to tell our students the exact way to solve problems. We'd rather that they discover that for themselves because that is more sustaining, more developmentally productive for them. If they can find the paths themselves, if they have the scaffolding necessary to approach a problem, that is exactly what educators want students to develop. So I've been teasing you in a sense with this build-up to Polya's method, talking about critical thinking skills. Indeed, Polya anticipated these topics that we talk about today, critical thinking and problem solving. He didn't use these words. Well, he did talk about problem solving, but he didn't talk about student-centered learning or problem-based learning. However, the things that he set down, his ideas, anticipated all of these current topics of interest in education. Some, 70 years ago, 1945? More than 70. And as I said, you'd expect that a book on how to solve problems, even if it were just a book on mathematical problems, would be huge. It is not. This is the entirety, not of Polya's book, because he has many examples, but this is a distillation of Polya's 4 key principles to solving problems. The book is only about 90 pages, as I recall. You can find this sheet on the internet. by Googling Polya's problem-solving techniques. You can send me an email, and I'll be happy to send you a copy of it. And we'll drill into each of these here in the rest of the presentation, which is only about 10 minutes or so, and then we'll have time for questions at the end. So I hope this is a pleasant surprise for you, because this means that the power of Polya's method is relatively easy to teach. It's relatively easy to practice. And I hope, as you'll see, or I hope that you'll see in the examples that I have, that it is quite a powerful system, despite its simplicity. So we want to activate these critical thinking skills. We want to unlock these abilities in our students. Here's how Polya says we should approach problem solving. 4 steps. And we'll drill into each of these. So let's apply these 4 steps. I don't know what areas you're all involved in and how you could apply Polya. A computer science example wouldn't be good. So let's talk about a general example, and I'll leave you to do the application for your area specifically. Let's apply Polya to solving a puzzle. Polya's first principle, understanding the problem. Anyone solving problems, any stage in life, needs to clearly understand what the problem is. I've seen students in my classes time and again start answering a problem. In class, on a test especially, and they go off on a tangent. They don't wind up addressing a key problem. I'm sure you've seen this if you're helping students with a writing project, etc. Understanding the boundary conditions of the problem, what's desired in terms of a solution, is key to approaching the problem. Having a student restate the problem in their own words is a powerful approach. Drawing a picture or diagram for a certain class of problems is helpful. Maybe the problem specification doesn't have enough information for you even to begin. Maybe you need to ask more questions before you're able to solve a problem. Let's consider this first step, devising a plan, understanding a problem in the context of a puzzle. Why do people always have the box for a puzzle sitting near the puzzle itself? Well, the answer is simple. It's the picture. That's the guide. Without that key piece of information, you would have no idea how to assemble a puzzle. You might, as this picture shows, have the corner pieces completed and the sides completed. You might find a few pieces that match inside the puzzle, but you'd really have no idea where to go from there because you wouldn't have the information of what the puzzle's supposed to look like when it's completed. So understanding where you need to get to is a key first step. Polya's second principle, devise a plan. How do you choose among the different pathways that are out there for solving problems? Well, he lists several, and the book outlines all of these with specific examples in mathematical contexts. Not calculus or something like that, it's simple mathematics, and you're welcome to read his book. You can find it online. What are some of the approaches that Polya suggests? We've already talked about guessing and checking. Considering special cases. In the context of a puzzle, corner and edge pieces are those special cases that allow you to start making progress. Looking for patterns, solving simpler problems, working backwards, being creative. All of these things are necessary to take those initial steps in solving a problem once you understand what the problem is. So, working to complete the puzzle. Polya's third step, persisting. This is this 99% perspiration. Maybe it's not 99%, but there is definitely an amount of work that is involved in problem solving. Once you decide on an approach, you need to stick with it, at least for a time. You need to see how well this is working out. This notion of stick-to-itiveness, what in the popular literature today is being referred to as grit. I'm sure you're aware of this, but this ability to have a flexible mindset, to stick with a problem that is challenging and not give up. That's key. Students need to see this play out. They need to realize that work is definitely required. And this is more of this difference between problems in the classroom versus problems in the real world. Maybe they're used to sticking to something for a very short amount of time because classroom problems are simplistic. So in the context of a puzzle, time is definitely required. There are false starts. You need to walk away. You need to come back. You need to look at different areas. The last step, and from my experience in the classroom, probably the most ignored step by students, but also by faculty, anytime that a problem-solving activity is engaged in a classroom setting, you must help students look back. If you're helping students solve problems from a class in a support capacity, do not ignore this step. What could be learned from solving the problem? What approaches were productive, which were not? How can this key step help students reduce problem spaces in the future? How can they approach new problems with this additional learning? And what I see happening in educational settings time and again is that students move from problem to problem to problem, and it gets to be very much a cycle that does not include this reflective moment, this capacity to improve. And if that's missing, we're clearly doing our students a disservice. So that is a look into how to solve it. I'm sure you've got questions. We'll get to those in just a bit. But what should you do to become experts at Polya's method? It's quite simple. You just need to practice it. What do I mean? Well, I would suggest that you take that sheet, that one-page, four-step sheet distilling Polya, and model your problem-solving approaches to, modify your problem-solving approaches to include Polya's model. So it could be any sort of problem, how you're dealing with shopping for groceries amid a pandemic, how you're dealing with work-related problems, but actively apply Polya's 4 steps, understanding the problem, devising a plan, etc., etc., so that it becomes a reflex action for you. If you are teaching classes, if you are teaching workshops, if you are working with students one-on-one, give them a copy of Polya's approach. Use that to structure their approaches. Demonstrate how Polya's methods can be applied. In essence, I'm urging you to master Polya yourself and then teach this to all of your students. What could be simpler? It's one sheet. This is not something that requires a 2-week boot camp. Get students to fit the problem, the puzzle pieces together themselves to solve problems. This diagram is particularly useful because there are 4 steps to Polya's method. So actively focus on unlocking this problem-solving capability. We talk a lot about critical thinking and problem solving, and then we just kind of wave our hands. How do students do it? Well, we hope that they learn it, but we don't really have a specific method. Or I should say we didn't really have a specific method. Or perhaps I should say we did in 1945, but that over the years it has somehow been largely forgotten. Well, everything old is new again, and you are now aware of Polya and are able to use this. Let me close with just a couple of kind of resonances. When I say everything old is new again, knowing what I know about Polya and other things, it's interesting to see it resurface. not just within the past week, but just recently, although he doesn't get the credit that he deserves. This is a great resource. This is Farnham Street. I would suggest that you subscribe. That's its address. You get a weekly email about thinking, about being creative, about teaching and learning. It's not particularly or not solely a resource for educators. It's more for people concerned with thinking. And I find it to be quite useful. Well, one of the things that Farnham Street published recently was an article on so-called elastic thinking. And I've said that we're kind of going back to the future. Look at some of the advice that Farnham Street shared in this article. What's that first piece? It's exactly how I began, talking about the beginner's mindset. Unfortunately, didn't reference the book on meditation here, but was curious to me to see this beginner's mind concept resurface, right? From Suzuki's book. What else did they say? Generate lots of ideas and don't be bothered that most of them will be bad. I'm sure that now you recognize where that comes from. Polya didn't get credit in this article as well, but their ideas are resurfacing, right? This notion that problem solving is a complex task and that there should be a way that we can navigate it with a little bit more intelligence, a little bit more of a method than just hoping to hit on a creative idea. And lastly, let me just say a word about another concept in our sphere, this notion of lifelong learning. I'm sure you recognize the name Adobe, software giant, Adobe Photoshop, Adobe Acrobat. Well, I came across this quote recently from the HR head at Adobe, and let me highlight a key part. It was actually this quote that inspired me to give this presentation today, because here is a person who's hiring, and what do they want to hire? Students with critical thinking and problem-solving skills and a desire for this lifelong learning. Obviously, if you're adept, if you're practiced at problem-solving, you know how to approach the problem of lifelong learning. I thought this was a fantastic synergy with Polya. And remember his quote that there's a general set of tactics to tackling all kinds of problems. It's that exact skill that we talk about so much these days as a desirable thing for our students to have. This unlocking of a problem-solving skill set in all learners. So that's how to solve it in a nutshell. I'm sure you have questions. Let me thank you for attending today's session. And I'll give you my email if you'd like to contact me. Happy to send you a copy of a Polya sheet, but you can also find it yourself with an easy Google. And let me exit here, and we'll take questions if there are any.
Absolutely. Thank you, Dr. Chris. Our first question is, can heuristics be described as best practices in this framework?
I would say so. Heuristics are not things that are bound to world of education. I hope my screen is now gone.
It is.
Okay, good. And my camera is not on because I look like a hobo these days. Anyway, yes, I would say that heuristics are an element of a best practice approach, which Polya articulated with his 4 steps.
Awesome. Our next question, there's been a lot of discussion in recent years about how some of today's careers are being replaced by robots in the not so distant future. Would you say this makes the case for incorporating problem solving in the classroom and perhaps in turn encouraging students to choose careers that involve problem solving? Thank you.
Oh, I like that question because I'm a computer scientist. And there's a great company that publishes demotivational posters. I'm sure you've seen motivational posters, in offices, but this is kind of a subversive company. And two of the ones I remember is a picture of people sitting around a table, and it says meetings. And then underneath in small print, it says, because none of us is as dumb as all of us. And I think that's a great description of kind of groupthink. The other one is something about automation. And it says that if you've got a job that can be easily replaced by a robot, then there's something wrong with your job. Yes, I do think that technology will replace many less creative jobs. So for example, delivering packages by drone instead of navigating traffic on a car or a bicycle or something like that. That's a job that I can easily see being replaced. And that is a perfect reason for educators to emphasize problem-solving skills, because computers are not yet creative thinkers. They have made great strides in artificial intelligence, but they are still not able to create a simulation of human mind, and may never be. So the more you're able as a student and a graduate to do things that automation can't, namely solving problems that are novel, that are unique, that are new, and not focusing on repetitive tasks that could be automated. I mean, that is a real career advantage.
Thank you, Dr. Chris. Our next question is, does the speed of change and thought today present challenges to understanding the problem, implementing the solution, and sticking to it? The fluidity of constant rapid change seems to be a new or most pressing obstacle. Could you comment a little bit?
Well, I see the point, and now I've just discovered where the questions are, so I can read it as well, which is helpful. There is definitely a tendency to romanticize the past and catastrophize the present. I wish I could take credit for that phrase, but I can't. I forget who said it, but I heard it somewhere. And I think that there is this catastrophization tendency in saying, oh my gosh, we've got so much coming at us today, and it's difficult to solve problems and so forth. Yeah, but we also have tools at our disposal that they didn't have in the past, that take many of these challenges and make them easier. Calculators, for example, solving complex mathematical problems. So I would say that there are certain things that present challenges to attention, namely students being distracted by multimedia and telephones. But I don't think that those are challenges to mentally, physically, viscerally understanding problems or implementing solutions. I think they are more challenges to our attention overall, our stick-to-itiveness overall. And perhaps a part of this is that problem solving has traditionally been presented, as I outlined during the presentation, in very simplistic ways, or with grand kind of hand waves that, watch, I'll pull a rabbit out of the hat, so to speak, like a magician, and the problem is solved, obscuring from our students many of the kind of messy situations that are involved in an expert's mind solving a problem. So I think Polya can present a pathway forward, a light in the darkness, so to speak, so that we can see and teach students about how to approach problems without the kind of distraction and the hand waving, but with a real specific workable technique.
Thank you, Dr. Chris. There's a question that came in and says, could you please recommend some workshops that we can do with students to help them develop problem-solving skills?
Um, hmm, that's a problem right there. I would suggest applying polio. I mean, that's the focus here. So as a first step, let's get some sample problems from students' classes. And armed with nothing more than Polya's 4 steps, I would sit down with students and I would ideate, brainstorm. How do we do this in this context? Polya is not something that you can present or learn in the abstract, which is why I ended with this notion of practice being required, of not just walking or talking the talk, but walking the walk. You have to do polio yourself to appreciate the power. So any problem that you face is an opportunity to apply polio's 4 steps. So that's what I would suggest doing. And it would probably mean more to students by far to solve actual problems that they are wrestling with rather than abstract classroom problems, if you will. Look for problems that are occurring in their everyday academic experience.
Someone mentioned that we can always read about similar problems that have been raised in the past and analyze how they were solved to start conversation for a new problem-solving method.
Absolutely, that would be Polya's 4th, looking back, having an awareness and rather an appropriate notion considering Polya described all this in 1945. And there's wisdom to be found because our problems have changed over the years as new technologies, new problems have surfaced, but the approaches by and large have not. And I notice a question, Tiki has posted the link to that particular worksheet. So super.
And someone actually asked, "What's the most important part of the method?" And is looking back and analyzing actually the most important part of polio's method?
Well, it'd be tough for me and perhaps presumptuous, and I think Polya's work is fantastic, and I urge you to read certainly the worksheet, but the book isn't bad either. He's an excellent writer. For me, it would be step 2, where it's the approach to the problem. Looking back is definitely vital, but it's in working with students in my field in computer science, it's those first steps. You're faced with something. How do you even get a toehold? How do you get a handhold on the problem and start the climb to a solution? And that initial aspect of problem solving is a great challenge for many students that I've seen. So any ways that I can help them start making progress, I think are valuable.
And our current final questions, can dealing with current situations in terms of how students learn help students develop their own problem-solving skills?
With the current situation, you mean the pandemic and how students are learning here? If that's the case, yes.
Yes.
In that case, definitely. I don't want to oversell, well, maybe I do, polio. I mean, once you're aware of this, and if we could raise hands, I'd ask you how many people had ever heard of George Polya or how to solve it before today, and I would imagine that nobody had, unless we have some mathematicians in the audience. So literally any problem can be approached. Maybe not every problem can be solved with Polya's methods, but it is certainly a way to approach problems. And it's, as I said previously, that approach is what is so challenging for students. That simple problem they can approach. The complex problems, the multiple paths forward is difficult for students. So yes, our current issue with the pandemic is a very real life problem. If you look at, in other presentations at my university, I've been playing up the notion of people hoarding toilet paper. You've probably seen this on the news. Tiki, if you've seen this? Of course.
Absolutely, absolutely. Stores have limited to one per customer.
And my point in making this is, in the context of my other presentations, that our first reactions to problems are probably not very good and probably wrong in many respects. And so why would you hoard tissue paper? I would say that in an educational context, educators rush to use video conferencing is an initial knee-jerk kind of reaction that is probably an incorrect one, because there are formidable technical problems for students, for faculty. Much better, in my estimation, to record presentations over PowerPoint with what's called a narrated PowerPoint, and have students watch those at any time, rather than try to get all on and conduct a simultaneous session. So I mean, that's just one example of looking at the problem, understanding the problem, and exploring possible solutions beforehand could have helped us approach our dealing with the pandemic differently. So back to the question, absolutely. Apply polio whenever and wherever possible. And I see a question: without problems, science and problems would not bring us creative ideas and solutions. Well, yes, but you know, it's kind of a chicken and egg thing. Do you get the creative ideas before the problems, or do the problems breed creative ideas? What is the interplay between creativity and solution? Other questions? I think my time is just about up.
Dr. Chris, this is Tad. I do have one final question, if I may, before we wrap up here, and thank you. And that is, as you were describing Polya's approach, it made me jump to the plan, do, act, check cycle, and there's some parallels there. But what my question really sits in knowing that in our current circumstances, knowing that even when we are face-to-face on campus, we're limited sometimes in how much exposure we have to students. So is there a particular forum or a particular medium you think would be a great way for us to introduce this to students that's concise, that is impactful, again, knowing, you know, not just where we are now, but, you know, hopefully in the fall when we're back on campus and so forth. So do you have any recommendations on how we can enlighten students with this in a very succinct and effective way?
Well, I'll tell you what I do. And yes, Tad, you're right that there are similarities with other problem-solving approaches, plan, do, act, and things. They all owe their roots to polio, whether that's acknowledged or not. Personally, I like polio a little bit better because there are more explanations underlying his 4 steps, more justifications. In my own classes, polio forms an integral part of my teaching. I distribute that sheet to students, and we work with that from very early in the semester in virtually every programming. I said I'm a computer scientist, programming problem solving act that we do. And what I want is students to internalize this as a method, because well, if you teach computing, you certainly are familiar with students kind of sitting there pressing keys randomly, not knowing how to begin. And for me, polio provides that beginning step. I realize that none of you or few of you are going to be computer scientists, if any, but a workable approach is to find a current problem from classes that your students are taking, and to work with them using Polya's sheet in hand, on a screen, whatever, and get them to internalize by practice, applying these 4 steps and working towards a solution. And something I want to say here is that the heuristic element is key. As student support professionals, you know that the worst thing to do is to tell students, well, here's the answer, because they won't have learned anything. And Polya's heuristics definitely do not tell answers. They instead provide that guiding light for each of the steps.
Dr. Chris, before Tad wraps, I have to read a comment from one of our participants, and I completely agree. They thanked us for the great presentation, and they said that you should create a doctorate in offering and presenting content. So thank you so much for what you've done for us today.
Well, you're welcome. And I hope everyone stays healthy and happy. I think it's going to be a long summer for us in the GCC region.
Yes, thank you, Dr. Chris. Again, I want to reiterate what Tiki mentioned. I think this was a very insightful session, excuse me. And I agree with your comments that I think Polya is a foundational approach to a lot of these other processes for problem solving and for planning. So I think it's a great way for us to take a step back and kind of look at how we approach things and how we get our students to connect with some of these key skill sets, such as problem solving. So. Again,
Super.
Thank you for today's session. Really appreciate it. I just want to, before we close here in the next minute, I just want to draw people's attention to tomorrow's schedule. We do have 2 sessions at 9 a.m. Arabic Standard Time tomorrow. The first one is counseling versus coaching within the career services arena in higher education, and that will be a session entirely in Arabic. And at the same time, we also have the Tale of Two Cities, Global Citizenship and Its Impact. That will be conducted in English. Then at 10 o'clock, we have 2 sessions, again, one in Arabic and one in English. So we encourage you to join us again tomorrow, same time slots for 4 concurrent sessions happening tomorrow at 9 a.m. Arabic Standard and 10 a.m. Arabic Standard. So again, Dr. Chris, Tiki, and for all of you who've joined in today's sessions, we thank you and we hope to see you tomorrow.